Let's try to understand what is bias and variance. Bias is where we measure the difference between the predicted value and the true value. Or in simple words, in lame words, let's say I asked you, what is the result of 2 by 2? Now we already knew the true value is 4, but for some reason, let's say you answered 3. Then the difference between these two values, which is 1, is the bias. Okay, so this is bias in short, is between the predicted and the true value. So you can think of it if we're talking about models. So we are seeing how the model is doing in light with the true value. So this is about bias. Variance, let's say if I ask you 2 by 2, and then you tell me, well, 2 by 2 is 3. And then you go study again, and then you come back and I ask you 2 by 2, you tell me 5. And another time I ask you, I tell you 2 by 2, you tell me 4. The point is, variance is we're measuring how different these values among each other, right? So they are all about the predicted value, about your answer. These all figures are the answer of 2 by 2 done by you. So variance is we are measuring how different these results are from each another. Okay, so this is variance, this is bias. And same as the figure shows us. So the green one are the predicted value. So variance, we are measuring the difference, or in other words, the distribution between among these figures. While bias is we are measuring how far your predicted value from the target value or the true value. Now, how to put these in perspective when we talk about overfitting and underfitting. Now, in order to understand, remember, overfitting is a case where the model memorizes everything, right? It doesn't actually capture the trend, but it tries to memorize the training data. So I like to think of it as a student who actually failed to understand the actual concept behind the course and decided just to go with memorization, just memorizing everything. Now, imagine this kind of character, this kind of student. Now, when it comes, let's say the lecturer has picked a problem from the training materials that the student has studied, right? Has memorized, in other words. What would you expect his result to be? Let's say his result is going to be very good, right? Let's say he has achieved A, right? Because he has done very well. Correct? Now, in other words, the bias is going to be small. Okay, so the perfect answer for all the question, the assessment question, is going to be, of course, A, right? And the student has achieved A. And why is that the reason? Because simply the student has memorized the training materials. Okay, so in this sense, bias is going to be low. Okay, so far so good. Now, about variance, variance is going to be high. And why is that? Now, as we said, if we use the training material, the student is going to achieve A. How about if I use materials the student has never seen before? Okay, so I'm gonna just type here. This is TR for training, TS for testing, or in other words, just unseen material. Just think of it as unseen material. Since this student actually has failed to capture the concepts, the sense of the course, so of course it's hardly is going to achieve any high mark, right? So most likely is going to achieve what? Probably C. And now if you are the lecturer, you're going to be surprised, right? Why the student has achieved high mark while here low mark? And the answer is, of course, because the student has just memorized the course. And when the lecturer has passed a problem from the training material, the student managed to answer very well. But when the lecturer has decided to go with a new problem or problem similar to one here, but he has made changes inside, so the student has failed to do any better. So in other words, the variance is going to be high, right? The variance is going to be high between the training, measuring the student using the training material, and the unseen material or the test material that is meant to be unseen. Correct? Is it clear? So in this case, overfitting, the variance is going to be high. How about underfit? Underfit, if we are still using the same example, is about student actually he didn't put enough effort to study the materials or to study the course overall. He didn't just do well. Maybe he just attended the classes and then turned away. But actually he didn't bother himself or herself to go back home and put any effort. Now, if we are talking about how it's gonna be when it comes to the assessment, right? So we can say, well, of course, he's gonna have high bias because his answers are going to be far away from the correct one because he didn't study. So what would you expect from him to do, right? In overfitting case, because he memorized, so memorization has helped him, right, to achieve low bias. But in this case, the student didn't put any effort, so his bias is going to be high. How about variance? Variance is going to be low. And how is that? Simply since this student didn't study at all, or he didn't bother himself to do any good. So let's say if the lecturer has decided to pass the training material, a problem from the training material, what would you expect the student to achieve? He's going to do bad because he's not studying. Regardless if you are picking a problem from training data or unseen data test set, it doesn't matter. So let's say he's going to achieve C. For some reason he just passed, but with low mark or very low mark. And then when the lecturer assess the student with other materials, which is unseen, okay, for TS, so guess what he's gonna do? Also bad. It doesn't matter, right? He's just not doing any better. It doesn't matter because he's not putting any effort. So when he has done the training, is gonna be bad. When he do on the test on unseen data or unseen material, is going to do bad too. Correct? Or maybe FF. Okay, so you got the point. Now, if we check how much they are different, they're nothing much, right? You won't be surprised because you already knew the student doesn't study. So there's nothing to wonder about. So in this case, if you check C, C, or FF, or even C plus C, so the variance, in other words, is going to be low, right? The variance is going to be low in this case. And this is in short the difference, or when we talk about the concept of bias and variance in light with different problems, overfitting and underfitting. So this is another figure to show you the case. So overfitting, as we said, the student memorize everything. Okay, so when we use the training material, the error that is going to achieve is going to be low. But when he is being assessed by materials that he hasn't studied, correct? So the error is going to be high. Like the case when the student achieved A, and then on the test is achieved C. While the underfitting, as you see the line, actually doesn't capture the trend. In other words, as the student doesn't put any effort to capture the concept of the course. So you already expect the output was going to be. So the error is going to be high. So it's going to achieve C when you use the training materials. And if you apply the test materials, so also maybe here C plus, here C. Correct? So the bias first is going to be high, of course, because his mark is far away from the true. And when it comes to the variance is going to be low in this case. Okay, so the variance here low, the bias is high. Here just the opposite. The variance is high, but the bias is low. So the variance is high because the student actually has achieved 2 different marks when 2 different materials have been used. Okay, I hope that has clarified the idea of overfitting, underfitting, plus what bias and variance are all about in connection to overfitting and underfitting. And of course, the optimum case where the model doesn't memorize but try to capture the trend or the pattern resembled inside the dataset, manifested inside the dataset. And in this case, guess what? Since the student has captured the sense or captured the concept behind the course, so even when you use the training material, the error is going to be low. And of course, the test error is going to be low because it's going to be able to use the concepts, to apply the concepts that he understood or she understood. Okay, so in other words, we are looking for the best model where you have, the best model going to be where you have low variance, low bias.